This is the third video on solving algebraic equations for Math 60. So let's take a look. We've covered a bunch of concepts so far on methods of solution. So let's look at the first problem on this assignment, number 2, the first even problem, 8x plus 7x equals 60. So the idea here is to use the concepts that we learned about combining like terms. If you have 8x's and 7x's, then together that makes 15x. And now we can just divide on both sides by 15, and x equals 4. Okay? So that process is relatively straightforward. Let's look at problem 6. We've got 3y minus 5y equals negative 9. So 3y minus 5y will give us negative 2y equal to negative 9. Divide through on both sides by negative 2. And y is going to be positive 4.5. If you like fractions, call it 9 over 2. Either one is fine. Okay, let's see here. All right, problem 8. Let's see here. We've got 2y minus 7y plus 17 equals 20. So here, it's important to be careful, be aware that the y's are like terms, the 17 is not. The 17 is going to get moved over here with the 20. First, let's take care of this. 2y minus 7y is negative 5y plus 17 equals 20. Now we want to move the 17 over to the other side. Minus 5y equals 3. And then divide on both sides by negative 5. And so y, you can call it negative 3/5. If you do the division there, 3 divided by negative 5, you should get negative 0.6. And either one of those answers is fine. Okay, let's see here. Then we get to something like, let's say problem 12. Here we've got 4 times x minus 7 equals 10. So this is the concept that we talked about with the distributive property, where you can distribute this multiplication across the subtraction that's inside the parentheses. So this will be 4x minus 28 equals 10. Now we add the 28 to both sides. So 4x is 38. Divide on both sides by 4. And so here, let's see, if you do 38 divided by 4, that looks like 9.5. If you like this as a fraction, you would need to reduce this, and I think this would be 19 over 2. And so either one of those answers is fine. Okay. Problem 14. Let's see, 6 times x minus 1 is negative 30. So same process here. We just want to distribute this 6 into the parentheses, so we get 6x minus 6 equal to negative 30. Then we want to get rid of this 6, cancel it out by adding 6 to both sides. So now we have a 6x on one side. Be careful with this calculation here. Negative 30 and positive 6 will make negative 24. And then if we divide on both sides by 6, x ends up being negative 4. Okay. Now if we go over onto the second page, problems get a little bit more complicated here. Problem 18 let's see, we start off 3 times 5 plus 3x minus 8 equals 88. And there's a variety of ways to go about solving this one. I'm going to distribute first, distribute the 3 into the parentheses. Notice that we don't multiply by the 8 because it's not inside the parentheses. So this will be 15 plus 9x minus 8 equals 88. Now here you can add the 8 over and then subtract the 15. You can look at this as positive 15 minus 8, and that would give us a positive 7. And if we do that, then we can subtract 7 on both sides, come out with 9x equals 81, divide on both sides by 9, and so x is equal to 9. Now you could have done that problem a little bit differently, and I've talked about this before, how you have choices about how you want to go about doing things, so long as you follow the rules of algebra. So I'll just show a little slightly different method for solving this. You can add the 8 first if you want to. There's nothing wrong with that, nothing preventing you from doing that. That would give you 96. And then distribute through and subtract the 15. And you come out in the same place, right? 9x equals 81, divide on both sides by 9, and so on. You could even conceivably, at this point, I don't really recommend it because people have a tendency to make mistakes when they do this, but right here, you could divide on both sides by 3 and cancel that out. And that will leave you with 5 plus 3x equals, what is this, 32. Subtract the 5. And then we come out with a different problem at the end, or a different equation at the end, a different step, but we still get the same answer. X equals 9. X equals 9. Same thing. So those are all valid ways of solving this. I think this is the easiest to understand. There are some things in here that get a little bit tricky, but there's nothing wrong with any of them. I just find that people have a tendency to make mistakes when they try to do those processes that are a little bit tricky. Okay, let's see here. Let's look at problem 20. And this is something I talk to people about in really all of the algebra courses that I teach, 60, 70, 95, and even in Math 111, I make a big deal about this. 10 minus 3 times 2x minus 1 equal to 1. So here's the issue, is that a lot of people see that 10 minus 3 and they think, that's the easiest part of this. I'm going to do that first. 10 minus 3 is 7. But that's not what you have to do, right? Because the order of operations says that you have to do that multiplying before you do any adding and subtracting. And so the 10 is just going to stay here and wait until we distribute the 3 into the parentheses. That'll give us minus 6x plus 3 equal to 1. And again here, you can move these over to the other side separately, or you can add them together on this side first. Now notice how this 6x held on to that minus sign in front of it. And that's a really important idea. Talked about that when we were doing like terms and the order of operations. How the sign for a number or an expression is always what's in front of it. Okay? All right, so now we want to subtract 13 on both sides. This will be negative 6x. Over here we'll have negative 12. And if we divide on both sides by negative 6, we get x equal to positive 2. All right, let's see here. Problem 22. Here we've got 7y minus parentheses 4 minus 3y equal to 11. Okay, Similar situation that we saw here, right, where we just left the 10 alone when we've distributed. Here we're going to leave that 7y alone. And remember that this is a hidden -1. And if you want to think of it as just distributing the negative sign, that works as well. But the 7y stays the way that it is, and then we get -4 and then a positive 3y equal to 11. And then we'll add our like terms together. Again, notice that this 3y is a plus 3y, and a plus 7y makes 10y. That negative sign is attached to the 4. And then we'll move the 4 to the other side. And that'll give us 10y equals 15. Divide on both sides by 10. Y is 1.5. And if you like fractions, you can call it 3/2. Okay. Now, I often tell people about mathematics is that, when you're just practicing a single concept, like in some of those problems that we did on the distributive property, you had like 5 times 3x minus 1. And then you distribute it, you get 15x minus 5. And I can give you 10 or 20 of those problems to practice this. This is not the difficult part of mathematics, right? When we're doing a single concept and just practicing it over and over, that tends not to be all that difficult, all right? The difficulty comes when we learn a couple of concepts and then you get a problem where you've got to use these different concepts at different places in solving the problem. That's what's really at the heart of mathematics, and that I think also translates to a lot of other disciplines, both in academics and in real life. When you learn a single thing and practice it, it's pretty straightforward and pretty simple. Sports is like that, right? When you have practice for football or basketball or whatever it might be, you practice a single skill during your practices, but then when you go to play the game, right, you've got all these different things happening at once, and you try to remember, what are these skills that I learned in practice that can help me during the game? So that's sort of what these problems are more like, okay, is that you've got to make decisions about what to do and when, and that can sometimes be challenging. All right, let's see here. So that was 22. We've got 2 more to look at. Problem 24, 4 times 2y minus 1 minus 7 times y plus 2 equal to -2. So here we've got two sets of parentheses where we have to distribute. This first one will get 8y minus 4, and then this one minus 7y minus 14. And we still have that -2 on the other side. So now we want to group our like terms. We've got a -7y and a positive 8y. That makes positive 1y. And you can just call it y if you want to. There's nothing wrong with that. And then we've got a -4, a -14. That makes -18. And then the last step is to add that 18 to the other side. Those cancel out. We're left with just that 1y. -18 and positive 2 make positive 16. Okay, one more here. Very similar. Problem 26 is very similar to problem 24. And so let's see, 4 times y minus 3 minus 6 times y plus 1 equal to 8. All right, so like I said, this problem is very similar to number 24. We're going to distribute first 4y minus 12, then distribute here, -6y minus 6, and that's all equal to 8. Then the same thing we did over there, identify your like terms. You've got a 4y here, a -6y here. That'll make -2y. And then -12 and -6 make -18. So, again, add the 18 to the other side gives us negative 2y equals 26. Divide on both sides by negative 2. And so y ends up being negative 13. And you can always plug this back in to check your answer. I don't do that every time, and I don't ask that you do that every time. But if you're ever curious, because that happens to me sometimes, I get an answer and I'm like, is that right? And so you can check and find out. So let's see here. We've got 4 times negative 13 minus 3. And then minus 6 times negative 13 plus 1. Is that going to give us 8? Well, let's see. This is going to be negative 16 here. This is going to be negative 12 here. So let's see. 4 times negative 16, that's negative 64. Negative 6 times negative 12 is positive 72. And yeah, 72 minus 64 is 8. And so it checks out. Okay? So like I said, I don't ask that you do that for every problem, but if you're ever not sure, you can plug it in there and double check your work. Okay, so we're going to have one more of these solving equations assignments. And then after that, we'll move into a different topic. And as always, if you have any questions, please let me know. Thanks.